We are on the final review packet, and so I've skipped a few sections because they're really just function machines and all that stuff, so I figure you guys can handle that. We're going to start right away with exponents. I've given 4 problems on the board right here, and we're just going to go ahead and see how these go. One of the things I want you guys to remember, please, at all times, move all of your negative exponents first. I chose these problems because they have negative exponents in them, so I want to make sure we know how to do it. So what I'm going to do with A is I'm going to go ahead and just apply the negative exponent into the 4. Remember, negative exponents move things from top to bottom or bottom to top. Because the 4 is on top, it will move to the bottom. That negative 2 will become positive 2, and then I will square the 4, so it becomes 1 over 16. This problem here, remember, exponents only affect the thing that they're touching, which means the negative 2 is touching the x, meaning that is going to be the only thing that moves to the bottom with a positive exponent, and then it'll just stay there. There's nothing else I can do to that. With v, you can do this a number of different ways. I'm going to go ahead and multiply the numbers together first. So negative 5 times negative 2 is positive 10. I'm actually going to do something kind of odd. I'm not going to move my negative exponents down just yet. I'm going to actually combine them out, and because the x's are being multiplied, I can add the exponent. So what I'm looking at is negative 2 plus 3, leaving me with x to the positive 1, or just x. And then the y's will combine out. Y to the first times y to the negative second. 1 minus 2 becomes y to the negative 1. And at the end, I have a negative exponent. I'm going to go ahead and call him 10x over y. With u, since I have top and bottom stuff happening all over the place, I'm going to go ahead and follow my first rule. Move all negative exponents up, so the y to the negative 1 comes up. It becomes 18x squared y all over 30x to the 5th. From here, I'm going to take care of my x's. I've got x squared up top, x to the 5th on bottom. That leaves me with x cubed on the bottom because I have more x's on bottom. The y won't combine out with anything. 18 over 30. They both divide into 6. So I'm going to go ahead and reduce it by 6. 18 divided by 6 is going to become 3. And 30 divided by 6 is going to become 5. So your final answer ends up being 3y over 5x cubed. And that's as far as you need to go for all 4 of these answers. As always, guys, exponent rules are fluid, so just stay flexible with them. Generally speaking, just move your negative exponents first. And here we are writing equations of lines. Remember, guys, in order to write the equation of a line, you need a point and a slope. If they don't give you the slope, they're going to give you another point so that you can find the slope, just like they do in A. So because it goes through these points, I can use this information to find the slope. So I can say that m is equal to 3 minus negative 2 over 6 minus 5, which is going to give me 3 minus negative 2 is going to be 5 over 1, so that is my slope, or just simply 5. From here, I'm going to go and pick one of the 2 coordinates. It doesn't matter which one I choose. Most people go for the double positive ones. I'll do that just to keep things simpler. So I'll use 6, 3 as my coordinate, and I'll write the equation of the line. So what's the equation of a line? Y equals mx plus b. In the case of our example, y equals 5x plus b, because I know the slope. So again, because these are the coordinates, I'll go ahead and replace the y with a 3, and I'll go ahead and replace the x with a 6 and a plus b here. And I'm just going to solve for b. So I get 3 equals 30 plus b minus 30 from both sides. So you get b equals negative 27. So your final equation is y equals 5x minus 27, and that's as far as you can go. Let's go and look at D. D is actually ironically easier, even though it's later on in the packet, because in this one they already give you a slope. They tell you that m equals negative 2, and it passes through negative 6, 5. So we just have to set this thing up. So y equals negative 2x plus b. I'm not even confident you need to show this step, but this is what I'm thinking. So I say 5 is equal to negative 2 times negative 6 plus b, and then 12 plus b equals 5. So if I subtract 12 from either side, I get b equals negative 7. So my final equation is going to be y equals negative 2x minus 7. And that is how you write the equations of lines. And the last thing is our favorite, sequences and series. So for us, let's go ahead and just look at these again. I know that they're difficult, but we can do it. First thing to determine is the first 4 terms that they give them to you, 7, 11, 15, 19. We should identify that getting to the next term requires us to add 4 each time. And because we're adding, that makes this type of sequence arithmetic. Okay? Arithmetic. And if you want to write a reason, that'd be great. That way it'll help you write your explicit and recursive equations. It's because you're adding 4, right? Whenever you add or subtract a value, a consistent value, to your sequence, it's going to be arithmetic. So because it's an arithmetic equation or arithmetic sequence, we can write an explicit equation for it. So we can say that t of n is equal to, well, it's going to be 4n, right? Because 4 is the common difference each time. It's like the slope of this if it was going to be a line. In order to get this next term here, this next little piece of the equation, I have to find the 0th term of this sequence. So the 0th term, it looks like if we're adding 4 to move to the right of each piece, that means I'm going to have to subtract 4 to move to the left, which makes my 0th term 3. So that means my explicit equation is t of n equals 4n plus 3. Now here comes our favorite, recursive equation. The recursive equation is going to be the one that uses the previous term or the current term to use to call upon the next term. So how do I write that? Well, that's t of n plus 1, right? Because t of n plus 1 means the current term. And that's going to be t of n, which is the current term. And then how do I use the current term to get to the next one? Well, I just simply add 4 to it. Okay, so again, let's just go through this definition one more time. T of n plus 1, right? That is the next term. And how do we get that next term? This equal sign is kind of like saying is, right? And then t of n is the current term. And then the plus 4 is the how it changes. So we'll talk about that again in the next sequence here. So how would I find the 100th term? Well, to find the 100th term, I don't want to use the recursive equation, because if I'm going to find the 100th term, that means I need the 99th term. I don't know what that is. I'll use my explicit equation to say, hey, t of 100 is going to be 4 times 100 plus, I'm going to switch colors here because when I go to black, it doesn't show up as well, the blue. So 4 over 100 plus 3. What is that? Well, that's 400 plus 3, which is 403. And that is your 100th term of your sequence. So let's do the next one. 16842, it looks like we are multiplying by 1/2 to get to the next term. And because we're multiplying, it's going to be a geometric sequence, and that is because we are multiplying by 1/2. The explicit equation is going to be t of n is equal to some kind of thing raised to the nth power. If you guys notice today, inside this bracket will always be the thing that it changes by, so it'll be the 1/2. And just like this red piece up here in the arithmetic sequence, this will be the 0th term of the sequence. So, if we're multiplying by 1/2 to move to the right, we're going to divide by 1/2 or multiply by 2 to move to the left, making the 0th term 32. Because 16 times 2 is 32, 32 is my 0th term. Again, recursive equation. Next term is current term and how it changes. So the next term is always going to be t of n plus 1. Is always equals. The current term is always t of n. And then how it changes. Well, that's going to get multiplied by 1/2. And that's as far as you need to go with the recursive equation. The 100th term, that's going to be hard to find actually, but we can at least show what it looks like. 32 times 1/2. Again, I'm going to switch colors because I'm moving to the black part of the screen. It'll be raised to the 100th power. I figured I'd do one last one because when they mix up the information for us, it gets a little harder to do. So from here, it looks like they give us the recursive equation. I don't have an explicit or a type of sequence or first 4 terms or 100th term. But what I can see from here is that the first term is 3. And it looks like to get to the next term, I would use the current term and multiply it by -2. So I think the next term in the sequence is -6. And then the next term in the sequence will be 12. And then the next term, the 4th term, will be -24. Again, how did I get that? The first term is 3, and each succeeding term gets multiplied by -2. And since I'm multiplying by -2, that will be a geometric sequence. So from here, what is the explicit equation? Well, that's going to be t of n is equal to something raised to the nth power. Well, it looks like I'm multiplying by -2 each time, so I'll go and just pop that in there. And then I got to find my 0th term. So what was the term before the 3? Well, it's definitely going to be negative because I'm going to be dividing by -2. So what's 3 divided by -2? -3/2. And now I can use this information to find the 100th term, which is going to be t of 100 is equal to -3/2 times -2. And again, I'm going to change colors just because I'm moving to the black part of the screen. The dark blue doesn't show up as well. 100. In a calculator, this would actually be insane. So you can just leave it as what it looks like. Alright, I think that does it for this portion of the final review. Go ahead and get to work on the packet and start solving some equations, writing some more equations of lines, doing those exponent rules, and all that stuff. Work on function machines also.